Okay, so this is the last section of chapter 1 of Griffiths' book on quantum mechanics, third edition, is the section 1.6, which is the uncertainty principle. So we are not going to derive or do anything mathematical about the uncertainty principle at this point. We're just going to try to get some intuition about it. Okay, so the idea that the book proposes that is the following. Suppose you have a rope and you are at the edge of this rope and you start oscillating. So you create some wave, okay? And which kind of information can we get about this wave? If we ask, where is the position of this wave? Well, that's a question that doesn't make any sense. The wave is everywhere. It's not in one specific position. So we cannot get any information about position. But we can get information about the wavelength, right? The wavelength is just the distance between two crests. So this we know very well. Now, suppose that instead of generating this wave, instead of shaking the rope as we did, we just give a jerk. And so just a quick impulse on that, and then we create this. So we have this bump that will be traveling. So this is where the bump is at a certain time. Later, it may be here and keeps on moving. So now, with this bump, if I ask, where is it? Then yes, we can say where it is in time. But now the problem becomes the wavelength. Makes no sense to talk about wavelengths here. Okay, so this is a property that you would have for any kind of wave. It's also for wave functions. Now, the wave function is a wave. So this also holds for the wave function. Now, there is something in addition to that. In the development of quantum mechanics, as we already mentioned, there were situations where we would talk about electromagnetic waves. So talking about waves, and so we would say that these electromagnetic waves, light could interfere, could have diffraction, but under other experiments, we would talk about photons, particles, for example, in the case of the photoelectric effect. Well, this motivated de Broglie, no, it's a French scientist, to extend this wave-particle duality, not just to light, but also to matter. Well, wait a second. If if light sometimes behaves as a wave, sometimes behaves as a particle, the same should be valid for matter. So electrons, protons, atoms, and so on, under certain situations, should behave as a particle, but under other situations, should behave as a wave. And what is this wave? Is the wave function associated with this entity that we are studying. And the wavelength of this wave is related to the momentum of the particle. So this is something that you may have learned in a course on modern physics. Okay, so conclusion of this story. Now, momentum and wavelength are related. I can write in this way, which means if we put in blue here, if we know the wavelength exactly, as in this first scenario up here, if we know the wavelength, that means we know momentum very well. But if we know momentum or wavelength, then we don't know position. It doesn't make sense to talk about position. On the other hand, so this is case one. Case two, if we know position now, if we know position, as in the case of the bump, the second case, then we do not know wavelength, which means we cannot know momentum. So that's the idea of the uncertainty principle. We know either one very well, but very precisely, and at the cost of not knowing the other. So this information is contained in the uncertainty principle, which is given by this equation. We'll learn how to derive this equation later in this course. But what this is saying is that the standard deviation in position multiplied by the standard deviation in momentum, so the uncertainty in position, the uncertainty in momentum, have to be larger than this finite value. It can never be smaller. So if we know this x very well, if this uncertainty in x is very small, from this equation, what you get, that the uncertainty momentum will be very large, and vice versa. And so this is the idea of the uncertainty principle, which we will know much better later, how more quantitatively later. So that's it. That's the end of this section.